This presentation is about the experimental and numerical studies on catalytic converter to reduce CO2 emission in IC engines. The main purpose of this project is to do numerical analysis and CFD for the catalytic converter to reduce and control the emission of CO2 and NO2 from the automobiles. One of the best material for absorbing CO2 is charcoal due to its high degree of porosity. In our experiment, we analyze the catalytic converter using different materials as absorbate, mainly activated charcoal and activated alumina. Next topic to be discussed is about introduction. The Ministry of Environment says that the air pollution from automobile exhaust is especially from a premium fuel or the SI engines is 70% of carbon monoxide and 60% of hydrocarbon. To lessen the exhaust emission, alternate technologies like alternate fuels using additives, fuel treatment, exhaust gas treatment, modification of engine design are being considered. But due to the major issue of controlling the CO2 and NO2, the catalytic converter plays a suitable role in reducing the exhaust emission. The performance and the design of catalytic converter has been arisen from the improvement to vehicle and pollution control code. Now we can see about the catalytic converter. The first and the prior step is the installation process of catalytic converter. For the efficient working of catalytic converter need to be at a temperature of around 650 to 850 degrees Celsius to produce the inert gases like CO2 and H2O from the emission of exhaust gases. For the purpose of fast heating, the first catalytic converter is kept close to the engines. This placement can cause several problems like vapor lock. In the alternate way, catalytic converters were moved to the third of the way back from the engine and were then placed underneath the vehicle. The next process is absorption. Absorption is the phenomenon of accumulation of large number of molecules at the surface of the solid or liquid phase in comparison to the bulk. In this absorption process, the distributor distributes the various emitted gases, exhaust gases, and the absorbent particles like charcoal absorb the molecules and make the oxides to dioxides, and the clean gas out gets outlet. Next we can see about the material properties and gas properties and its initial temperature and pressure at the inlet. The materials like platinum, rhodium, palladium, activated charcoal and activated alumina are the absorbate materials. The gases like CO, NO, CO2, SO, HC, particulate matters are the examples of elements which are contained in the exhaust emission from the automobile. The inlet pressure and the temperature is of about the pressure is about 0.5 megapascal and the temperature is about 1000 Kelvin. Slide is the design of converters. Converters consist of two sets, primary converter and secondary converters. The primary converter and secondary converters have the same set of arrangements. The catalytic bed is placed in the center and the perforated plates are placed both in the right and the left ends. The inlet and the outlet valves are shown. Next we are going to discuss about the numerical results. Let us discuss with the CFD analysis. In the figure 5, the meshing is done using an ANSYS software of a 18.2 with mesh grid size of fine 1.6 mm, which is enough to obtain the accurate result. In figure 6, we are showing the NO density. The main function of the catalytic converter is to reduce NO and CO2. The dark blue color in the above image shows the high NO density at inlet of the catalytic converter, which is dramatically reduced at the outlet. This is indicated by light color blue. Next figure 7, mass fractions of CO2 is shown. There is no reduction in the mass fraction of CO2, so it is given constantly a dark blue color throughout the entire catalytic converter. Next CFD analysis is about the pressure, temperature and mass fraction of NO. As I have already said that The major purpose of using catalytic converter is to reduce CO2 emission. There is no change in NOx emission, so the outlet of the emission controller remains same as that of the inlet. The entire emission controller is blue in color. This slide is about the mole fraction of CO2. There is a slight reduction in the mole fraction of CO2 at the outlet as compared to the inlet. So there is a dark orange color at the inlet and a light orange at the outlet of the emission controller. Next we are going to discuss about the testings and results. In this slide, the specification of the engine and the test results are shown. The engine was started to establish the recommended oil pressure and it is checked for any fuel, oil and water leakage. After the completion of the warm-up procedure, the engine was run on no load condition and by adjusting the injection of fuel, the speed was adjusted to 1500 rpm. For each loading condition, the engine was running at a minimum of 5 minutes and data were collected during last 2 minutes of the operation. Simultaneously, engine exhaust, the NOHC and CO and CO2 was measured. The exhaust gas analyzer is used to measure the exhaust gas emissions such as CO2 in terms of volume percent, CO in terms of the percent by volume, HC in terms of parts per million and NOx in terms of parts per million. The exhaust gas coming out of the engine is made to pass through the chamber with the help of the feedback system. The gas which has particulates along with other emissions is passed through the ATS system to remove CO, HC, NOx and PM. Then the CO2 rich gas is passed through the CO2 absorption chamber containing charcoal. The exhaust temperature is noted and ensured that it is below 2500 degrees Celsius at 1 bar pressure. The results obtained is plotted as graph. Graph is plotted with the conditions like with the reactor and without reactor and with load and without load. Figure 16 shows the oxides of nitrogen and figure 18 shows hydrocarbon, figure 17 shows carbon dioxide. The next part is the conclusion. The exhaust gases from the automobiles after passing through the catalytic converter can also pass through the emission controller to reduce the CO2 and NO2 emission by absorption technique, the ultimate resulting in low environmental degradation. On considering the ideal conditions from the experiment, it is clearly inferred that activated charcoal and activated alumina has the ability to absorb carbon dioxide molecules at normal pressure and temperature. Initially, without emission control device, there is a tremendous increase in CO2. But after the usage of activated alumina and activated charcoal, there is a significant drop in CO2. Overall, this experiment is a success on reducing the CO2 level. By reducing the CO2, the greenhouse gas level is also reduced. It also enriches O2 gas for the combustion. We conducted the experiment with the same setup with and without our newly designed emission controller on no load and 50% load condition. There was a drop in percentage of CO2 emission with the emission controller at both no load and 50% load condition. Here are some few references which guided me to involve in this paper. Thank you.